probably noticed Professor Cohn is a little bit more formal and wears a tie, and so when he's here I also wear a tie, but today we're a little bit less formal, and so no ties, but I'll probably have one on Thursday again. So just so that you knew what the code was. Now, Tom Moser is coming, yeah. So, you know, that was the generation where everybody wore ties, so I'll wear a tie too. Anyway. Okay, but despite the fact that we're a little bit more informal, that doesn't imply any intellectual informality. We are actually, I think, very fortunate that Professor John Logsdon, who is the director of the Space Policy Institute at George Washington University, which is part of their Elliott School of International Affairs, and we have a recent graduate of that program. He's going to talk to us today, and this is really going to be the last in the looks at kind of the policy which led to the original requirements on the space shuttle. And, you know, as we've pointed out on numerous occasions, when you're looking at systems engineering of any large-scale project, well, anything really, it's absolutely critical to get the requirements straight. And we can't really understand a lot of the technical issues with the space shuttle and the challenges that we had to face without understanding how it got to be that way. Professor Logsdon has written numerous articles about the shuttle, and I think you're going to give me do you have an electronic version of your science article? You don't. We'll have to dig that up. We'll give you a version of that. But before that, actually, I guess the work where he really achieved a national recognition was his book on the Apollo program, The Decision to Go to the Moon, which was a history of the Apollo program. Professor Logsdon is a recognized expert in space policy. You will see numerous articles by him in Space News, and he is often the first person who gets called by the New York Times or National Public Radio or one of the other media for comments on various developments in space. And actually, depending on how the talk today goes on the shuttle in terms of time, if there is some time left over, he's brought some information about the new exploration architecture, which was just announced formally yesterday. And given that we're setting out on another large space project where a lot of the same issues that we had to deal with about the shuttle will also apply, I think it'd be interesting for people in the class to start following what's going on in this new space system. So that's enough for me. John, I'll turn it over to you, and take it away.
Good morning. What I'm going to do this morning is somewhat different from what you just announced, in the sense that I'm not going to talk about the political history of the shuttle requirements as much as the political history of the shuttle and how the requirements interacted with that political history. So it may be the same thing, but I'm not a technical person, and get.
Well, you have a bachelor's degree
I have a
in physics,
yes.
which is a well-hidden fact. But
Yeah, almost before next Tuesday is the 100th anniversary of the publication of the equation E equals mc squared. And my degree in physics is almost before that. Not quite. Okay. One of the things we've been doing at George Washington University seemingly forever, and close to it, it started in 1990, is a project to collect the seminal documents that define the evolution of the U.S. space program. There are now 6 volumes of this size printed. We're working on 7, and there's one more to follow, called Exploring the Unknown. Jeff thinks that it's in your library. I'm going to try to get an electronic version of what I'll just talk about in a moment to put on your class website. The volume 4, which is Dr. Hoffman has at his home, not in his office, deals with access to space, and one section of volume 4 deals with the shuttle. And that's what I'm going to try to get an electronic copy of for you. So what I've done is build this talk around the original documents that that trace the policy history of the shuttle. And I'll use them kind of as backdrop. As NASA approached the end of the Apollo program, its leaders, or at least some of them, were thinking about what followed Apollo. And at that time, the head of I'll say manned space flight, and apologize for the gender-specific language, but that indeed was what it was the Office of Manned Spaceflight in the late 60s. Its head was a very creative character named George Miller, who is still active. He's one of the founders and moving spirits in a thing called Kistler Aerospace that wants to provide alternative commercial access to space. Miller gave this talk, as you see, August of 1968. As far as anyone can tell, it's the first use of the term efficient Earth-to-orbit space transportation system and economical space shuttle. Miller's concept of the shuttle, which had a lot of influence in one strain of its development, was rather grandiose in character, especially the notion that the shuttle would operate in a mode similar to large commercial air transports and work in and out of major airports. Landing would be completely automated with prime dependence on spacecraft guidance, with ground control backup. And then this is a long talk. It's in the book I just mentioned. But then, he says basic design could be applied to point-to-point transport if the space shuttle were used as a global transport. Safety and comfort standards could be comparable to those of a large transport jet. It was probably not like business class in a 747.
Maybe like the Concorde. But that's certainly what they were talking about with the National Aerospace plane. That, I mean, if you can develop a plane that can take off from a runway and fly into orbit, and you remember when we talked about the rocket equation, we tried to make it clear why this is such a difficult thing to do. But if you could do it, then you don't have to go all the way to orbit. You can just go halfway to orbit and land in Tokyo after you take off from London or New York.
Right.
So,
and this kind of holy grail reduction in cost by 2 orders of magnitude. So that was the mental set of the guy who I would call at least the policy father of the space shuttle, is that you could have an aircraft-like operations, 2 orders of magnitude of a level of safety and reliability and operability that it could even be used for commercial transport. As you know, NASA was successful in carrying out its mission of getting humans to the moon in July of 1969. When Nixon came into office in January of 1969, he had a task force, a transition task force on space, and that task force told him that there was a need for some decisions on what to do after Apollo. With the focus on getting Apollo done, the then head of NASA, Jim Webb, didn't like long-range planning. He wanted the politicians to tell NASA what to do rather than the other way around. NASA was woefully unprepared for what it wanted to do after Apollo, and the country hadn't discussed it at all. Nixon appointed a so-called Space Task Force, Space Task Group, and asked it for definitive recommendations on the post-Apollo space program. That task group was chaired by the Vice President, who traditionally has had the space portfolio in most administrations. At that time was a well-known space expert named Spiro Agnew. You're all too young for that to even be a joke. He was later caught taking bribes in the White House and resigned in shame. He was a typical Maryland politician, which means corrupt. It's my home state. The Space Task Group was captured by NASA, by its then administrator, Tom Paine, who was a very bravado character. He told NASA that they should be swashbuckling. And by Miller, who had developed a long-range plan for NASA, and ultimately by Wernher von Braun, who was brought up to Washington to add the charisma to the plan. The report that was submitted by the Space Task Group to the White House 2 months after Apollo 11 had these recommendations for, for what NASA should do. This was what NASA really wanted to do. Mars, starting in 1981, 100-person, 100-man space base in the mid-'80s. The program that was recommended ultimately was Program 2, which had Mars in '86, and you see these comparative accomplishments. And in here was an Earth-to-orbit space shuttle for some time between 75 and 77. That's where the shuttle entered into national policy, was in Nixon's reaction, or in the country's reaction to NASA's post-Apollo proposal. Again, just to give you a sense of this kind of thinking at that point. I'm not sure where this came from, to be frank, but you take the station, the space base, and other stuff in this maximum program, and you see talking total space shuttle flights a year, peaking in '83 with 66 flights a year, including 34 to service a 6-man base and a 6-man orbiting station at the moon. So these truly grandiose ideas of what might be done.
I don't think it was ever clear why you had to go to the moon every other week in order to maintain a 6-man base either.
No, I think it was not every other week. It was.
30,
I think it was 3 month rotations of a crew.
But they've got 30, 40 flights a year, maybe logistics flights, I don't know.
Logistics, and you're doing two things. You've got a 6-person station in orbit around the moon, and why, I don't know, and a 6-person base. The architecture that was announced yesterday culminates in the buildup of a 4 or more person lunar base, with a passing mention that, oh yeah, someday we might go to Mars. By the way, you know, if anybody has comments or questions, interrupt me. Otherwise, I'll just drone on. Yeah, Larry.
To what extent was the space station's existence important for the shuttle back in the 70s?
It was a reason for its existence. At this point, the reason to have a space shuttle was to take crew and supplies to the station, period. At least in the core NASA planners' ideas. You had people like Miller, who left the agency in September of '69 with these very grandiose ideas. He was succeeded by Dale Myers, who I understand has already talked to you, and Myers was very instrumental in the negotiations that led ultimately to the decision to go forward with the station. I remember the first time I heard the word space shuttle. As Jeff said, I've been at this a long time. I finished the book, The Decision to Go to the Moon, published by MIT Press, but out of print. In late 1968, we tried to market it as a paperback, you know, put a rocket and a girl on the cover and the inside story of why Kennedy sent us to the moon. Didn't work. Had footnotes and all, because it was a PhD dissertation. And you know, talking to an audience like this, they understand what a PhD dissertation looks like. I went down to attend my first launch, which was Apollo 11, and for some reason he hadn't rented a car, so I was figuring on hitching a ride from Orlando to Cocoa Beach, and the person that I ended up driving to was a man named Leroy Day. Did you know Roy Day? Roy was at that time running the Phase A studies of the space shuttle. And he told me what he was doing. I said, that's the first time I'd heard of the concept. See, I don't know where this came from, but it is the kind of thinking of the need for this. So to go to your point, Larry, when NASA first presented its post-Apollo plans to the Congress in the spring of 1970, the program was called Station Shuttle. And they were coupled at the hip. And so it was the integral justification from the NASA side, although people like Dale Myers were already negotiating with their counterparts in the Department of Defense for potential military use of the system.
Although almost clearly this is before any military involvement or really commercial involvement came in, because when you look, there's only 2 unmanned satellites per year.
Yeah, well, and those are I mean, this is the manifest to implement this.
Right. Right. I mean, that was purely a NASA
Yes, yes.
program.
There was not much consideration of other users of the shuttle at this point, because this was enough to justify the investment in a new vehicle. I mean, again, the logic was that you could put these big things in space, like space stations, but the logistics costs would drive you crazy if you were doing it with expendables. And so the only way to operate a permanent outpost in orbit or beyond was to have reusability in the supply system, in the transportation systems. That was, in essence, the #1 requirement. Well, I don't know whether it was unfortunate, but in reality, the Nixon administration was not having any of this. Nixon made a statement in response to the Space Task Group report. As you see, March of 1970, so it took him 6 months to respond to the report. Meanwhile, NASA's budget was getting chopped to pieces. But it was essentially a fundamental 180-degree change in policy from Apollo. You know, Apollo was separate leaps requiring a massive concentration of energy. Space must take their proper place within a rigorous system of national priorities, must be planned in conjunction with all the other undertakings. In other words, space has to be compared in its priority to all the other demands on the federal budget. And at least for the Nixon administration, but in reality for every administration since, the answer has been essentially the same. I mean, when Kennedy made his speech saying we should go to the moon in 1961, the NASA budget jumped 89% the first year, 101% the second year, 38% the third year, and it's like a roller coaster that gets to the top of the first hill, and the program has been living on that momentum ever since. And you came down that hill very quickly. So that you see by the 73 or 74, NASA was down below this value is percent of the federal budget. So it's kind of a constant measure. As the budget goes up, NASA gets essentially the same share of the federal budget, about 7/10 or 8/10 of 1%, and has gotten that share for 35 years. And this, I would say, is the way the democratic political system makes policy choice is through budget allocations. And if you have the same budget allocation essentially for 35 years, I would say that's where space ranks in the scheme of national priorities according to the political leadership in the White House and Congress. Just to flip ahead to 2004, one of these fundamental premises in the Bush vision for space exploration is that NASA will stay at this level of expenditures. And that everything that you want to do, going back to the moon, eventually to Mars, has to be within that budget envelope. which means
And
you have to
remember
design to that.
The fundamental systems engineering triad we've talked about on several occasions: cost, schedule, performance. So that clearly demonstrates cost is a fixed parameter. We don't have the freedom for either for the shuttle or in this future program that cost is going to go up by very much.
Just in case anybody asks what these two blips are, this one is the replacement of Challenger after the 1986 shuttle accident. It's a one-time cost of building another orbiter. And this was Bush 41, if you may remember or know, announced a space exploration initiative on the 20th anniversary of Apollo, and he provided an increase in budget resources to carry out that initiative, which when Bill Clinton was elected quickly got undone, and you see the result in the past few years. So that, in a sense, that decision that space had to be planned in the context of all other priorities has had multiple impacts over 35 years. First thing is NASA's never accepted it and has always tried to do more than it has resources. And one of the things Jeff didn't say was that I was a member of the Columbia Accident Investigation Board after the last accident. One of the things we said in our report was that NASA had for too many years been trying to do too much with too little, and it created the kinds of stresses in the organization that led to some of the organizational sloppiness that was at least a contributing factor in the Columbia accident. It told NASA that it could not pursue in the 70s a post-Apollo program that was anywhere near its ambitions. And so NASA had to reinvent its program from what it had proposed in 1969. And by the end of 1970, this is how budgets get done. This is a letter from the then head of NASA, Jim Fletcher, transmitting NASA's recommendations for the next year's budget. This happened last Monday, September the 12th this year. NASA submitted its formal budget proposal to the White House. Every year that starts the process. Well, you can read all this rhetoric later, but NASA had decided that the key element in the program for the 70s is not the space station by now, but the space shuttle. It supports the last 4 of the President's 6 objectives, these 4. And reflecting that decision, NASA announced, we have made a major decision to defer development of a space station to a later time and to orient the space station studies towards modular systems that can be launched as well as serviced by the space shuttle. Again, a fundamental change in plans. The station that NASA was planning in 1969 would have been launched by the Saturn V, would have been 33 feet across, have lots of habitable space, be big, 12-person minimum, building up to a 50-person, maybe eventually 100-person outpost. This represented a major shift that said, number one, the shuttle becomes our number 1 priority, not the station, and the shuttle has to be designed to launch space station modules. That was the overriding NASA goal. And so I would argue or suggest that this decision made in late 1970 only separated in time shuttle and station, not that the intimate link between the 2 programs remained. It was just you're going to do them in sequence rather than at the same time. And here we are 35 years later, and the major issue in getting started on exploration remains, what do you do with the shuttle? What do you do with the station? They are now seen as mortgages that have to be paid, or obstacles to the next systems, or however you want to characterize. What this also meant is that the traffic model that was justifying the shuttle, of all these launches to space stations and lunar bases that you saw, was no longer operative. And so beginning at the start of 1970 and all the way through this 2-year complex decision process, the Office of Management and Budget kept saying, well, how do you justify this investment? You're talking about a multi-billion-dollar investment in the future. What is the justification for it? This was the first time in the early 70s that the White House, through its Office of Management and Budget, used cost-effectiveness analysis, a cost-benefit analysis, as a tool in budget allocations. It has not been done, certainly not been done in the space program of the 60s. But OMB insisted that NASA show an economic justification for this investment. And in order to make it come out the way OMB wanted it to come out, which was that there was no justification, how much economics do any of you get in this environment? Hopefully as much as, I've never had an economics course except with Jesuit undergraduate college called Christian Economics, which may be a contradiction, and never mind. But I'm going to say something I don't have a clue of what it means, which is that OMB insisted that NASA use a 10% discount rate, which is the future value of current money. And that's much higher than the discount rate applied to many other investments, because this was a long-term and risky investment. And so that meant that the economic justification for the shuttle had to be very strong. And throughout this process, there was this constant pressure on one hand to justify the shuttle economically. The only way that that could be done, absent a space station or an ambitious NASA program, was finding other users. And this goes back to your comment earlier. NASA became not just a kind of suitor of the military as a user of the shuttle, but the economic justification for going ahead with the shuttle became totally dependent on the military willingness to use the vehicle. And military is a euphemism. Many of the payloads that were being discussed there were intelligence payloads operated by the organization called the National Reconnaissance Office, which at that time, the existence of the National Reconnaissance Office itself was classified. So you could not say NRO satellites. You can say it now. NRO its existence was declassified in 1992. But at that point, it was all called Air Force or DoD satellites, many of which, including the most demanding, were intelligence satellites. So the primary determinant of the size of the shuttle's payload bay was the width was the ability to launch space station modules. Professor Young may be able to comment. If I understand it right, the kind of human factor studies at the time said that people would be unwilling to live in tubes less than 14 feet across for long durations. And so the shuttle had to be able to accommodate a 14-foot wide module. The length could be adjusted. But the military payloads, think Hubble. Think Hubble pointed down rather than pointed up. And that, I think there's been enough discussion of it that I'm not revealing classified material. Though the reconnaissance equivalent of Hubble was the next generation reconnaissance satellite, and that was basically 55 feet long. And so the decision was that you needed a payload bay 60 feet long in order to capture many military and reconnaissance payloads. And that was a determinant of the size of the payload bay, which again drove the size of the shuttle. The other military requirement was the desire, well, there were two. One was a desire to be able to go into polar orbit, which meant a West Coast launch site. You can't launch into polar orbit from Cape Canaveral Air Force Station or Kennedy Space Center without flying over Boston. Actually, I guess you'd launch south, so flying over Miami and Cuba, which is, for range safety, is not a great idea. If you launch from Vandenberg Air Force Base out in California, you've got several thousands of miles of open ocean in front of you. The other was a kind of, the Air Force was in a nice position here because it could make up any requirements it wanted and impose.
We've talked about the cross range.
Okay, you've talked about it. All right.
Yeah.
So that's where the cross range came from. It was the, and so you've talked about cross range leading to delta wings, leading to heavier orbiter because of more thermal protection. But it was, all of that came from the requirement of getting the Department of Defense to say they would use the shuttle as a way of justifying to the economists the large upfront investment. And have you looked at anything like this?
We've seen a few early things, but not talked about it.
Okay, this is kind of from the outcome of the Phase A studies in the late 60s and early 70s. As you see, Phase B proposals, a bunch of studies, and then in June of 1971, a rapid shift so that in 6 months the configuration evolved to what was finally built. I presume if you've talked about cross range and that sort of thing, you talked about the difference between the preferred shuttle of Johnson Space Center and its chief designer, Max Faget, which was a straight wing, minimal cross wing, cross range shuttle, probably technically simpler to build and less expensive to build, into a delta wing configuration that matched the Air Force cross range requirement. What happened in June of 1971 was critical to this whole process. At this point in its studies, NASA had concluded to build a two-stage, fully reusable shuttle that would match the cross-range requirement and be big enough to launch space station modules, would cost in the order of $10 to $14 billion in investment cost, with a peak funding of $2 billion a year during the 70s. OMB in May of 1971 said, well, that's fine, but you can only have $5 billion with peak spending of $1 billion a year. If you want a shuttle at all, it has to fit within that budget curve. And I presume Aaron and others are going to talk about the kind of hectic trades that got from a fully reusable shuttle to first moving the liquid hydrogen tanks outside the orbiter airframe and throwing them away, then coming up with the idea that you could put both the external oxygen and hydrogen fuel tanks on the outside and throw them away, to the notion that you could use strap-on solids to assist in takeoff and move the orbiter down to the bottom so its engines could be used as part of the takeoff thrust, to the final configuration. At that point, June to December 1971, there were not zillions, but hundreds of different variations of shuttle design being floated around, and other designs to do something that was approximating but not totally, totally, what's the right word I want to say, totally meeting all of the payload requirements that had been laid out. I'm sure you're going to be talking about a lot about this, of the engineering choices that were involved in this, and I'm not capable of talking about them. But as apprentice young system engineers, the notion that you could go from here, totally different concepts, to here in 6 months and know what you're doing should make you a little nervous. So why was the shuttle ultimately approved? OMB, the Office of Management and Budget, was on one spectrum of the participants in this debate. It really didn't believe, its staff did not believe in the value of human spaceflight. Its staff was and is the guardian of the federal budget, believed it was under the policy guidance of the Nixon administration to cut federal expenditures dramatically across the board. And so OMB, through this whole process, through a variety of interventions and changing demands on NASA and political interventions, getting leaked information from the aerospace industry and asking NASA nasty questions that it didn't want to answer. OMB, the career staff of OMB, they say, in retrospect, went too far in trying to kill the shuttle. So they were at one end of the spectrum. NASA was at the other end, obviously, because by now, 1971, the shuttle was a survival project for NASA as it viewed itself as a large organization built around human spaceflight and developing new and large-scale systems. Yeah, Larry.
On the subject of the career staff at Congress and their power.
OMB, not Congress, is what I'm talking about. Well, but ask your question.
Well, the fact that non-elected staffers, I was thinking congressional staff.
Yeah, but OMB is the same
have
thing.
enormous influence over not only implementing but making policy.
Yeah.
And they stayed long after their terms of many congressmen.
Any of you heard of Paul Shawcross? I wouldn't think so. Paul's an MIT graduate. He's the examiner for human spaceflight in OMB right now. He did a TPP master's up here 10 years ago or so. And he is leading the fight to ground the shuttle. Now, nobody knows his name unless you're inside the Beltway and play that. I mean, one of the comments, one of the things I'll say, Larry, in reaction to where you were going, is at least the career staff on the Hill are relatively accessible. So if you're an aerospace industry operative, you know who they are and you can talk to them. Particularly back in this period 35 years ago, the OMB staff operated under a cloak of anonymity, weren't open to talking to industry people. It's changed a lot over the years, and were able to operate behind a wall of secrecy and push their agenda into national policy. It is my belief, after starting my 40th year in Washington, that, God, it's a long time, that most people outside of Washington think that Congress matters, but almost all the decisions that matter are made in the executive branch, and Congress just snips at the margins, 2 or 3%. Yes, sir.
Yeah, can I finish my question? How much did industry lobbying affect the design of the shuttle? Because I mean, you look at it, and every major aerospace company had a piece of the shuttle. They were getting money from it. I assume they also were probably lobbying their senators for places like Stennis Space Center.
Well, there wasn't a Stennis Space Center,
but yeah, I mean, how much did industry?
Well, if you look at this a little, all of industry had study contracts. This is Grumman, which was a separate company at the time that had built the lunar lander. And Boeing, before it bought Rockwell, or this was North American Rockwell that had built the Apollo command module. This was McDonnell Douglas. So the major aerospace companies each had a concept, and they were lobbying or contending for the adoption of their concept rather than what you see now, which is work shares of a single concept. But this was a decision totally inside the executive branch at this point. Congress was more or less supportive, with the exception of one senator, Fritz Mondale, Walter Mondale, who kept asking some difficult questions. And NASA had its preferred concept. This MSC here is Manned Spacecraft Center, what's now Johnson Space Center. And it was Grumman and McDonnell Douglas that came up with the idea of putting putting rockets on the side. At that point, they weren't necessarily solid rockets, to enable a cheaper configuration. What you ended up with was the preferred orbiter of the Manned Spacecraft Center, the NASA orbiter, after all these design requirements, with the Grumman-McDonnell Douglas concept of a expendable external tank and recoverable strap-ons. I don't want to say solids. So what came out of this was an amalgamation of everybody's ideas. And I said in passing, I'll say again, one of these industry firms, and all evidence points to North American, had a relationship with the OMB that was feeding OMB questions that would embarrass their competitors, or result in not doing the shuttle at all and continuing on with the existing systems where North American was building at least the Apollo command module. Players in this included the economic analysis. Here is a report that was given as this debate heated up to NASA in October of 1971, done by a company called Mathematica, which was founded by Oscar Morgenstern. Morgenstern was an economist at the Institute for Advanced Studies in Princeton, and his young colleague Klaus Heiss was and is an Austrian, somewhat crazy economist. Again, that may be the same thing, crazy and economist. And they had the contract to do the external economic analysis for the shuttle. And they came up through their analysis with the conclusion that a reusable system is economically feasible at the current level of activity, and that a thrust-assisted, that's the strap-ons, shuttle is the economically preferred choice. And, this is economists designing technical systems, another thing that would make me nervous. And this goes back to your comment earlier. The demand for space transportation by NASA, the Department of Defense, but particularly by commercial and other users, is the basis for economic justification. The economic analysis had as an input a demand model that was totally unconstrained. It's everybody's wish list of things that might be launched but weren't funded for the next 15 years. And that's where the next round of shuttle launches, 50 or 60 shuttle launches, which was part of the image at the time the decision was made, came from this demand model, which was done by the Aerospace Corporation and given to Mathematica to play with in its economic analysis. It's not clear how influential this set of recommendations was in the final decision to proceed. I don't, Klaus Heiss, who's still very active, claims it was very influential. I tend to think, well, you'll see why, my explanation of why the shuttle was chosen. These are the kind of economic comparisons that were talked about. The launch vehicle investment costs, non-recurrent, were clearly much greater for the new shuttle system. But the recurring costs of operations were much less than using the current system. What is that? Almost $6 billion. This is 514 space shuttle flights over a 12-year or 11-year period. 11, I guess. So that's, what, about 48 or 49 flights a year was the model that was being used at this time.
It always, but it always interests me when people do modeling like that. You notice they chose the number 514, not 513 or 515. I mean, it's sort of, it gives you the impression that they know what they're talking about.
Yeah, false concreteness.
Right. You know, if they had just put approximately 500, that's really as much as anybody knew at the time.
That's the number that will make it work, I suppose.
Now that would be rigging the analysis, wouldn't it?
Round the numbers are at the bottom too.
Yeah, well, one of the things to watch here is that a lot of the cost were payload savings. There was this illusion at the time, it's proven to be an illusion, that because of the characteristics of the shuttle, you could make the payloads much less expensive. You didn't have to design them to space program standards if you want. So here the payloads, instead of costing $18 billion a year, we're only going to, or over this period, we're going to cost $12 billion. So that's $6 billion savings in payloads. And it's that combination of operation costs and payload savings that give you the $7 billion advantage in the economic argument for going ahead with the shuttle. Bush 41 later used the term, which I think is properly applied to this analysis, calling it voodoo economics. And I think most of the people involved in this decision recognize that. In a technical decision, the White House often at this period in time depended on its Office of Science and Technology, now called OSTP, Office of Science and Technology Policy, and its President's Science Advisory Committee, now called PCAST. President's PCAST, what does PCAST mean? President's Council of Advisors on Science and Technology. And so the science advisor was actually an engineer, not a scientist, named Ed David. He commissioned a PSAC, President's Science Advisory Committee study, to look at the shuttle and as a basis for, or look at NASA's proposals as a basis for the position he would take in White House debates. Chair of that study was Alexander Flax, who was head of the Institute for Defense Analysis, president of the Institute for Defense Analysis, a think tank in Washington. And this was a kind of summary report that Flax sent in of the panel. Doubt that a viable shuttle program can be undertaken without a degree of national commitment over the long term, analogous to that which sustained the Apollo program. It may be attainable, but it's certainly not apparent at this time. It's a long letter, and I'm just going to look at it and show you a couple of things. In retrospect, I think this advice was sound advice that was provided. Maintaining a program is large and risky, with the long-term prospect of fixed budget ceilings does not bode Some decisions have been taken which introduce additional hazards to the success of the program technically, operationally, and economically in order to reduce projected peak year funding requirements. At that point, I think the strap-ons, the firing the main engines at liftoff, I can show you the analysis in the letter, but I think that's what he was talking about. Basically what the PSAC panel recommended was postponing the decision for a year or more while some of the uncertainties were studied. General view: no significant role for manned spaceflight in military and civilian or science. Didn't believe NASA's suggestion that the shuttle would allow experimenters to conduct their activities in spaceflight. Evoked no enthusiasm from the scientists. You can counter that, obviously. This shuttle was not a wonderful laboratory for most applications. The scientific community in large doubts the potential benefits of the space shuttle. Manned spaceflight should be considered contributions in terms of national prestige, international cooperation, exploration, and unforeseen future needs. Basically, the justification was really kind of arm-waving intangibles, some of which I think are very real, like prestige and cooperation.
Jump back a little bit to the science enthusiasm or lack of it. I think there was a clear division in the science community then between the quote real space scientists, that is,
Right, the outward-looking,
the ones who want to look out, and the life science community, which sort of came into its own with Skylab when it was realized that there was
Skylab was 2 years after this, Larry.
Okay, but we were at this point.
Yeah.
The life sciences community was betting that the interesting things were going to be happening together. But without any real data, Skylab was the first long-duration exposure.
And the life science community did not have the high step in the space science community at that point. Space science is dominated by physicists.
And in fact, even within the NASA hierarchy, I think at that point it was still part of space medicine.
Right. Yeah.
Chuck Berry.
Crew medicine. So yes, I mean that split was there. You know, it must be noted that new approaches have often not been recognized or appreciated by the putative users until after they've been demonstrated. Yeah, Mark.
Didn't Hubble then conveniently make scientists excited about the shuttle?
Some, but again, only after. We don't want to talk about why. We'll let Hoffman talk about whether the trade-off of putting Hubble in the shuttle orbit compared to it being serviced was a good trade-off compared to where you would want a telescope. If you had been designing this large space telescope in 1970, would you have made it shuttle launched?
Well, everything had to be shuttle launched then. I mean, given,
Well, I mean,
given the history of Hubble, you know, obviously, had it been put in an inaccessible orbit, we wouldn't have a space telescope now.
Yeah.
So what can you say?
Yeah. Again, the shuttle can't be justified on a purely economic basis for the unmanned portion of the program, so it's a position directly opposite the thing I showed you before. Must be justified on the basis of new capability, contribution to leadership and prestige, its unique value, if we're going to have intensive and frequent manned spaceflight. And you have to expand, postulate expanding rather than level space budgets over the next 10 years, and the Nixon administration said that wasn't going to happen. So again, the somewhat bottom line of the PSAC position led to the conclusion that if you had to make a choice in 1971, you had two choices. either proceed with the shuttle program now or soon, or drop manned spaceflight after Skylab. And nobody likes binomial choices like that. But in a large degree, that was the consideration, or the mental set as this debate came to the ahead towards the end of 1971.
Actually, that brings into sharp relief. Remember the comment that Professor Cohn made when he was talking about, you know, what should a systems engineer do when presented with requirements that you're not really happy with and don't know if you can meet, but on the other hand, recognizing as they came to that basically if they didn't build the shuttle that was being specified, they probably were going to end up with nothing at all. And I think what John just showed was you know, justification that in fact was the political environment at the time, that, you know, it wasn't the shuttle or something else, it was the shuttle or nothing.
Well, except at the end, people like PSAC and OMB kept suggesting alternatives. This was a chart drawn in November of '71 by George Lowe, who was the deputy NASA administrator and kind of the technical strength in this thing, showing the investment costs versus the, this is in billions, this is in millions, the cost of operations for various things. The two-stage fully reusable, $10 billion investment, low operating costs. The baseline 15 by 60 foot payload bay could be done, he's saying 8, within 3 weeks it was 5 billion. A phased development, develop a simpler one first, and then a more complex orbiter later, with the large payload bay, and various rocket assists, developing a smaller one, smaller payload, smaller bay, or developing a Titan III launched glider sort of thing. And the argument was in this curve, it made sense to pick something along this line, on the knee and the curve, on that basis. NASA made its last best case in a memo to the White House. The end of, this is dated November the 22nd. I think it shows up on the top. Look at these reasonings. This is really NASA's best case. Number one, the U.S. has to stay in the human spaceflight business. That is, you know, that's not subject to analysis. That's that's a belief. And NASA argued that this should be a policy premise, that the United States had to have humans in space, and the shuttle is the only meaningful new manned space program. The operative word there is new. You could have kept launching Apollo capsules and Saturn 1Bs or something. Saturn V had been canceled by then. Shuttle is the necessary next step for science, applications, military, position in international competition and cooperation. The cost and complexity is 1/2 of what it was 6 months ago. Again, as engineers, that statement ought to be very nervous, that in 6 months you can cut cost and complexity in half. Starting the shuttle now will have a significant positive effect in aerospace employment. Not starting will be a serious blow to both the morale and health of the aerospace industry. Let me talk about that last one. Those I think were NASA's 5 best reasons for going ahead. And employment impact was one of them. This is an undated memorandum from somebody within OMB. Peter Flanagan was Nixon's top person right at the intersection of policy and politics, who was overseeing the space program. Flanagan had asked for impact of the shuttle on the aerospace industry. And this is what came back. What's the program? Here's the additional employment impact on the engine program, Space Shuttle main engine. Not very much in early 70, this is 71, but in 72 fairly significant employment impacts in either California or Florida. And on the airframe, depending on when the decision was made to go ahead with the shuttle, the impact in 72, so not very big, but big enough. Peak of 70,000 jobs might ultimately respond. The number of actual jobs by the end of 1972 would be relatively small. Why do you think 1972? Yeah. You have to recreate the environment of the time. This was 1971. The supersonic transport had been canceled. Defense spending on Vietnam was ramping down. NASA had no new program. And in doing the article that Jeff mentioned on the Space Shuttle decision, I ended up one afternoon in of all places, Santa Fe, New Mexico, talking to John Ehrlichman, one of Nixon's top guys. He said they sat down in the White House and mapped NASA jobs on key election states and said, hey, if we want to win the 1972 election, again, this is political history well before your time. At that point, the leading candidate was Ed Muskie of Maine, who was viewed as a serious candidate. It wasn't George McGovern, who was, for better or for worse, not a serious opponent. So that the political people were worried about winning places like California and Florida, and saw in the shuttle program a way of providing the indication of future jobs in key electoral states. Some of the people I've talked to over the years say that at least for the top political levels of the White House, that was the major reason for going ahead with this program, was in order to have aerospace employment impacts for the 72 election. You can judge whether that's a good reason or not. The decision kept getting postponed till very late in the budget process. OMB kept asking for more studies. This was a letter to the deputy director of OMB, Cap Weinberger, later Secretary of Defense, which NASA said, we've concluded the full capability still represents a best buy, but in recognition of budget problems, we are recommending a smaller vehicle, 14 by 45, because that is the smallest that will still be useful for manned spaceflight, Reed Space Station. It won't accommodate many DoD payloads and some planetary payloads. And here are the numbers. I don't know whether you've seen these numbers yet, attached to this letter. This is what NASA was telling the White House last business day of 1971, what the cost of various shuttle configurations would be. You notice very little difference in the development cost of the configurations. 0.8 billion between a very small and less capable and the full size, fully capable. And the operating cost relatively low across the board. Look at that number, $7.7 million a flight. For a payload cost of $118 a pound. I think one of the points of your course, if I understand it, is to understand maybe where these numbers came from and why they were were they ever possible? I shouldn't bias the answer. Were they ever possible of realization? I mean, here is the heads of the leading technical organization in the U.S. government presenting these figures to the White House? Did NASA lose its technical integrity in this process? Was there any foundation for these numbers? Or were these total salesmanship? Are all, I think, valid questions. You said you took a 2-minute stretch break.
Yeah.
Let's do that, and then I'll come back with the answer of why they ultimately went ahead with the shuttle. It does look like we'll have time to do this. Since, so you might. Here's one of the CDs. If you want to load that. But you have PowerPoint built into this place. You have a projector built into this. Yeah, okay. I'm going to argue that the decision to go ahead with the shuttle was made before all of this last 6 months of or so of 1971 back and forth when it occurred. And the basis for that is primarily this memorandum written through the director of the OMB, George Shultz, by Cap Weinberger to the president, in which he's talking about the staff proposals for reducing the NASA budget, which included eliminating the last 2 Apollo flights and eliminating manned spaceflight. And Weinberger said in this memo to the president, I believe this would be a mistake. The reason for reducing NASA is because we cut it because it's cuttable, not because it's not doing a thing. That the uncontrollable programs that offer no real hope for the future, this is, remember, Republican administration, are eating up the budget. We do need to reduce the budget, but we need to do it on a reasonable basis. There's real merit in the future of NASA. And if you took NASA apart, it would be very hard to put it back together again. And he says stopping Apollo and not starting new programs would be confirming a belief I fear is gaining credence at home and abroad. Our best years are behind us. We are turning inward, reducing our defense commitments, and voluntarily starting to give up our superpower status and our desire to maintain our world superiority. America should be able to afford something besides increased welfare. Notice the underlining. And this came back with a handwritten note. I agree with Cap. That's Nixon. In my view, the decision was made with those 4 words. Yeah.
Out of ignorance, who's Weinberger?
Weinberger at that time was the #2 person in the Office of Management and Budget, longtime California associate of Nixon, became Secretary of Defense under Reagan. So who he is in a sense irrelevant, except he was a political appointee with and a trusted associate of the president. And basically, he was telling Nixon that that the reason for continuing the space program was image. I mean, again, read those words because they're interesting words. Not having a strong space program would confirm our lack of desire to maintain our world superiority. I showed you this December the 29th memorandum where NASA went to the White House and said, we would recommend the full-size orbiter usually, but with tight budget, we'll go with 14 by 45. That was a Friday, the 29th of December, or maybe earlier in the week. Anyway, over that weekend, New Year's weekend, 71, 72, somehow, somewhere, Nixon and his inner circle decided to approve the shuttle and approve the full-size shuttle. They decided if we're going to approve it, we might as well approve the one that NASA thinks is best. There was a meeting scheduled between NASA leadership and the president in San Clemente on January the 5th. This is written by George Lowe. For a historian, Dr. Lowe was wonderful. He dictated his notes every week on the events of the week and then backed it up with the documents. So, you know, that's like a treasure load for somebody that's trying to write the history of this. Met for 40 minutes. Here's what the president had to say. We should not hesitate to mention the military applications, routine operations, quick reaction times, solar power satellites. These kinds of things tend to happen more quickly than we expect. Nuclear waste disposal. He liked the fact that ordinary people would be able to fly in the shuttle. Preserve the skills of the people in the aerospace industry. In summary, President, we do not know of the things the shuttle will be able to do. It will open up entirely new fields. Did we think it was a good investment? We, the top two leaders of NASA. It's not a $7 billion toy. But he indicated even if it were not a good investment, we would have to do it anyway because spaceflight is here to stay. Men are flying in space now and will continue to fly in space, and we'd best be part of it, which was essentially what Weinberger had said 6 months earlier. And to me, that link, and in doing research in this area, I've talked to both Weinberger and Ehrlichman and others around that. It's that link of human space flight to a national image of the United States, plus the employment impacts in the '72 election, that were the fundamental reasons for going ahead with the shuttle. Now, you may make a judgment that those aren't great reasons, but there they were. Just finally, the decision was made saying January 3rd we would develop a shuttle with the big shuttle, and the only or major open issue was whether to use a liquid or solid strap-on. And that was studied for 3 months. Trade-off between future benefits and earlier savings. Liquid boosters have lower operating costs. Solid boosters have lower development costs. Conclusions here are heavily dependent on the mission model. The basic concern was keeping within the development cost of the shuttle, and worried later about, somebody else worried later about operating costs. That all of that argument led to a decision in favor of the solid booster. The rest of this is kind of irrelevant to that. Basically, with the OMB acceptance of this letter and the choice of the solids, the configuration was frozen. There were some things in it that I'm sure you'll talk about later. There was, at that point, a pad abort capability on the solids. I'm not quite sure how that would have worked. Somewhere along the line, and it's not clear to me, at one point the shuttle was going to have jet engines so it could fly to a landing rather than glide to a landing, and those were taken out. And I think it was after this, but I'm not sure. That's for you folks to. Yeah, yeah. So, as I said at the start, the technical requirements of the shuttle, now I want to say it a little differently, that the reasons for approving the shuttle had very little to do with the specific technical characteristics of the system. If my argument that the main reasons were national prestige, national image, aerospace employment, rather than the actual performance characteristics of a particular configuration, as long as the shuttle could be developed within a $5 billion a year peak funding profile, and as long as the shuttle could do things for the Department of Defense that made it useful to both civilian and military users. That those were the drivers of the shuttle decision, and the technology was derivative of that, rather than the other way around. That presented challenges, as I'm sure Aaron Cohen or Jeff have talked about, of developing thermal protection, developing a main engine, developing a vehicle that could operate in multiple flight regimes. But those were secondary to the decision, policy decision, that the country should go ahead with this capability. Questions, comments, reaction? Yes, sir.
One quick question. I saw one of those earlier things you put up that it was around 70, 71. Talked about first flight was 77 and fully operational by 79. I was wondering, it seems to me that you could really reduce things like peak cost, and you could spread out your development costs if you just said, we're not in a hurry, let's do it right, but let's take our time. And because there wasn't the race anymore. I mean, we had done the Apollo, we had beat the Russians. And I was wondering, what kind of time constraints played into this? Why they were trying to finish by the late 70s? Why not say, let's launch in mid-80s?
Well, it ties into the current situation rather nicely, in the sense that there was then, and I think is now, a perception that an extended gap in U.S. human spaceflight is not politically acceptable. And at that point, at the end of '71, the only human spaceflight missions on the books were 3 flights to the Skylab space station in 1973. The thing that followed that, the Apollo-Soyuz test project, had not yet been agreed on. That wasn't agreed till May of '72. So there would have been, from '73 to whatever future date, in a gap in Americans flying to space. And I think the general sense was that was not acceptable. Also, you had a workforce issue, of maintaining the workforce with something to do at Johnson, by then not yet Johnson, but Manned Spacecraft Center, Marshall Space Flight Center in Kennedy. And so you needed a relatively rapid development program so that you didn't either disassemble the teams and have to reassemble them later. And the same for the capability inside the industry. So this was a program that was paced within a budget ceiling to make full use of the space industrial base in a reasonable time frame. I think that's why I would say that. I mean, the dates were set on the basis this is the earliest we can do it on this budget profile. Yes, sir.
The decision to go for solids instead of liquids for the boosters was the development costs as opposed to the operating costs. And now in this new architecture, the plan is to use the solid rocket booster. And Griffin said yesterday it's like something like it's proven to be the most reliable launcher ever developed, or something. That's true.
You've launched 228 of them with one failure.
So, no, I agree, but at the same time, if the idea then, if they went for solid, to reduce development costs and sacrificing operating costs, is sticking with solids in the same configuration now, kind of repeating the same possible mistake.
Well, I don't know whether it was first. You seem to assume that going with solids in the first place was a mistake. That a liquid strap-on solution would have been a better solution, and
I'm not necessarily assuming that.
many have argued that.
It's not really clear that the operating cost of a liquid booster would have been less. One of the big concerns was you know, you have a liquid booster, you've got a real rocket engine on it, and what happens when that lands in the ocean? I mean, there were real concerns about could you clean up and reuse a rocket engine once it's been exposed to salt water? And we don't know the answer to that.
Maybe it's the time to segue, if we want to do this, to a quick look at the new architecture as it was presented yesterday, which is being driven heavily. The choices are being driven by budget ceilings again.
You know the drill. I've got to turn the lights on in order to be able to turn this on. So.
All right, everybody take a 10-second nap. You know, an interesting question mark is whether you would be making the same choices now if you weren't constrained by budget. Once again.
No, I didn't mean to assume that the liquid would be better than solid. Just the observation of the basis that the decision was made on.
Come on, at MIT, your systems would work. Should.
On in the back of it.
Looks like it's not.
Because you can't turn it on.
Right there. Yep. That one.
Is that on now? You sure you turned it on? What?
Is there a light on there?
Well, there's just a little bit of those little lights.
Absolutely nothing is happening. This is ridiculous.
I think it will be okay.
What?
So there's a green light just here.
It just came on. All right.
Yep.
It'll take a while to
Yeah,
warm up. But,
there we go. And how do I advance this, Jeff? Oh, with your computer? I don't like touching Macs, but
all right, if you don't want to touch the computer, I'll set you up
no.
even better here. Hold on just a sec.
What this is the, or at a certain level, what it isn't, is the briefing that is on the NASA website, which is a 10-page briefing. This was the 23-page briefing.
What is this?
I see all these Mac users.
Well, no, I just loaded a new operating system, and
So you fixed something that wasn't broken.
this is the first PowerPoint presentation I've given since. Press the key immediately to the right of the shift key. What?
I like the tuxedo.
Forget this.
Let's just do it this way.
Let's do it this way. So, all right, there's your advance. Pull it towards you, all right?
I'll just use this.
Well, all right. You said you didn't want to touch it.
Oh, I'm kidding.
Give you the option.
All right. That's interesting. The presentation I saw yesterday had a comma between September and 2005. So I don't know what this is. Let's see. This may be something totally different.
Well, I'm not responsible. I just
Yeah.
loaded what you gave me.
Right. There is a clear set of top-level requirements in this new vision. And you, if you're space types at all, you should know this. Interesting attempt to develop a rationale for exploration, which, as you see, is mainly intangible: curiosity and leadership. They're very much the same things that started the shuttle program. If you, this is about the only mention of Mars in the whole presentation. Is even though the president's vision says Moon and then Moon as a way of getting to Mars. But here's why Moon. And you're developing technologies that you're going to use downstream, and in particular, this Saturn V class. Saturn V the Apollo 17 Saturn V launcher took 117 metric tons to low Earth orbit. So this vehicle that's being planned is slightly larger than Saturn V. One of the few areas of technological innovation in this system is a new engine which uses liquid methane rather than liquid hydrogen as a fuel. Why? Maybe I'll ask the class. Why would you be interested in liquid methane? Yeah.
You manufactured on Mars?
Yep, precisely.
It's also a lot easier to store over the long term.
Yeah,
than
yeah.
Liquid hydrogen.
Yeah. But the main reason is that it is a potential resource that you could get in situ on Mars, and so you wouldn't have to carry it all the way out there. And you could get oxygen on Mars because there's clearly water. Yeah. Yeah.
Oh, this may be silly off topic, but I wonder if you could comment on what you think of the feasibility of Mars Direct or something like that.
Whether it's feasible or not, we're not going to do it. Elements of Mars Direct are in the NASA planning for Mars, which does a fair amount of in situ resource utilization. Maybe I should back up and say, what is this? Mike Griffin was sworn in as NASA administrator April the 14th. He had been convinced for a number of months that NASA's planning for implementing the Bush vision was proceeding at much too slow a pace and distributing money much too widely, including to MIT graduate students. Jeff will explain that if none of you were affected by it. And so he ordered on April the 29th a so-called 60-day exploration architecture study to develop a specific architecture for getting humans onto the surface of the moon. And this is the result. That architecture was basically finished by the end of July, and it's taken 6 weeks to get White House permission to release it. And so it was formally released yesterday. It was mainly because there were two reasons: because the senior people in the White House were on vacation in August, as we all know, so the OMB staff could sit and snip at this and say, well, you can put all this stuff down, but where is the money to carry it out? You have to show the business case that you can actually do this with the budget that's allocated, and it takes a little prestidigitation, I think, to do that. So this is what NASA's now said is its architecture for the next step in fulfilling our destiny as explorers. Safe, accelerated in the sense that when Griffin got there, the schedule for the first crewed flight of the CEV, Crew Exploration Vehicle, was 2014. And he wanted to close, and the shuttle hard date to retire it in 2010, and he wanted to close that gap, and thought that it might be possible to have the CEV as early as 2011. It's turning out it's probably not going to happen. Why is this just not Apollo over again, sending people back to the moon? Here are the arguments. 4 crew, all crew on the moon. You can go anywhere on the moon, not just in the equatorial regions. You can begin the build-up for permanent human presence in a lunar base, do in situ resources, and it's a more reliable and safer. The argument is that at least on ascent, you get almost a factor of 10 improvement in the safety. Well, I'll show you.
And how is that going to happen? I mean, if
you
look on top,
well, there are specific charts on that later.
Yeah, okay.
Although this has been the system is being designed from getting to the moon backwards, it can also be used for the International Space Station if we continue with the space station. What are we going to do on the moon? Learn to operate away from Earth, do science, learn how to use local resources, develop one mission at a time, a lunar base, and develop techniques for the eventual human missions to Mars. So there's another Mars mention. A science group picked a bunch of places that were interesting. I believe this was primarily a drill, because going in, NASA knew that its preferred site was the Shackelford crater at the south pole of the moon. Why? Shackleton, pardon me. Because of the possibility of water ice, which would be a very valuable resource for in situ utilization. And you know, each mission will go to the same place and begin to leave on the surface the elements of a long duration base. How is this going to be done? It's first you're going to have this heavy lifter launch the Earth departure stage and the lunar lander. Then you're going to have the smaller rocket launch the crew exploration vehicle. They're going to rendezvous in Earth orbit, fire up the departure stage and head off to the moon, arrive in low lunar orbit, and then the lander will separate and come down to the moon. So this is the lunar orbit rendezvous method that was used for Apollo, plus an Earth orbit rendezvous step. Work on the moon, come back and rendezvous with the CEV, come back, probably ablative heat shield, for what is hoped to be a land landing in the western United States, in Oregon, Nevada, or California. So you don't have to deploy the fleet. The hope, but it's what the contractors will confirm, is that most of the CEV will be able to be reused up to 10 times by replacing just the heat shield. That's the hope.
That is not put in as a requirement, which is important. It's a desire.
It's a desire, yeah. Because they don't know they can do it. The baseline design is 4 crew to the moon. The thing can actually carry 6 people, either 6 people to the space station early on, or 6 people to a Mars transit spaceship downstream. It can also be used, if you take the crew accommodations out, as either a pressurized cargo module going to the space station and bringing stuff back from the space station. It provides down mass capability, which is missing after the shuttle goes away. Yeah, the Apollo capsule was 3.9 meters across. This is 5.5 meters, 32-degree slope on the capsule. So you get, it's a much larger capsule with hopefully better characteristics. NASA's calling the bluff of the commercial industry. It will issue shortly a request for proposal with $500 million behind it that says, you demonstrate, the commercial sector, demonstrate the ability to have cargo or maybe even crew delivered to the space station, and we'll buy those services. We won't use CEV. But in case you can't demonstrate it, the CEV will be able to be a space station transport and crew rescue vehicle. I don't think anybody believes that in the relevant time frame, anybody in NASA believes in the relevant time frame, the private sector is going to develop crew transport to an acceptable level of reliability. Maybe cargo. This is National Space Transportation Policy was issued last January that said that there should be full utilization of the evolved expendable launch vehicles, Delta IV and Atlas V. And that caused a problem because NASA said, well, for our purposes, we're going to build something else. And part of the price of that is NASA agreement to use primarily Delta IVs and Atlas Vs for its robotic missions. Problem with that is those things are expensive, a lot more expensive than Delta IIs. And where does that leave people like Elon Musk and space exploration in privately developed launch systems? Griffin was party to a study commissioned last year by the Planetary Society that came out with the conclusion that a shuttle-derived launch system was the best way to approach this. This study examined that system, shuttle-derived, and a number of possible alternatives, and came up with this conclusion. So this is the so-called stick. The first stage is the current solid rocket booster on the shuttle, 4-segment solid rocket. There's a new upper stage which powered by some version 1 space shuttle main engine, liquid hydrogen oxygen fuel, a capsule on top with a service module and an escape tower. Now you can say, why is it safer? It's because the crew is above any debris, and if something bad happens in the first couple of minutes with the solid, you've got an escape system to pull the crew away from it. And so NASA's probabilistic risk assessments say that this is a much safer system. You want to comment on that?
Well, I mean, the probabilistic risk assessment, I think is fairly obvious. If your escape system has a 90% probability of working, then you have cut down whatever the reliability of the main rocket. You've just increased your survival probability by a factor of 10 if the rocket blows up. Now, if you listen to some of the stories that Professor Cohn has alluded to, and we'll probably talk more about that, there were some serious questions in Apollo about how well the ejection rocket would work throughout the flight regime, and he said everybody always breathed a sigh of relief when the ejection rocket was jettisoned, you know, in the course of the launch. But nevertheless, there was we've never used it in the U.S. space program, but there was one example of a Russian Soyuz, which they did have a pad abort, and the crew was pulled off the pad by the ejection rocket
at a very high G load.
Yeah, like 15 Gs or so, but they survived and went on to fly again.
You want to comment on the comparison of that to your level of confidence on return to launch site aborts on the shuttle?
Well,
which was never done, thank heavens.
It has never been done. We'll actually talk about some of the abort schemes for the shuttle in more detail, and I think I'll leave it for that. But there's no question. The only way to survive in the shuttle is for the shuttle itself to survive. So we now have the capability either of returning the shuttle to the launch pad and landing, or going across the ocean. But if you can't quite get back for a landing, we do now have the capability of, I showed you the pictures of the escape pole. You can actually bail out of the shuttle now, but it has to be under controlled flight. I mean, it's definitely, there's no system of just extracting you out of the
I mean, the whole logic is that this is claimed to be an order of magnitude safer for the crew on ascent.
Well, I think the other point is that the solid booster by itself is more reliable. You don't have, you know, right now for the shuttle to have a safe launch, you have to have both solid rocket boosters work, plus all of the 3 main engines. So you've got a lot more failure points. This is a simpler system, so only one solid booster, and then the second stage is your liquid rocket. So there are a lot fewer things to go wrong. Plus the whole aerodynamics is much simpler because it's a simple stack formation. So I think, you know, just from an aerospace design point of view, it is a simpler
Apparently
and
there were
a
some
safer system.
some concerns because this thing was so tall of bending and that sort of thing.
Yeah,
I mean,
that's something they'll have to deal with. But
Yeah.
we've launched tall, skinny rockets before, and
Yeah.
I suspect they'll be able to figure out how to do that.
The heavy lift is built around something derived from the Space Shuttle external tank, with 5 versions of a throwaway version of the Space Shuttle main engine, plus 2 5-segment solid rockets. So it's adding 1 more segment to the existing booster. The upper stage will be powered by 1 or 2 derivatives of the J2 engine used for the upper stages of the Saturn V. So this is a pretty retro system. But it was a good engine. And
Yeah, I mean, the other thing to mention when you talk about, some people had suggested using the 5-segment solids for the crew launch vehicle. I mean, one of the other things when you talk about reliability is, as John said, we've had now 228 launches of the solid rocket boosters, and one of the great things about the recovery is not just the economic impact of being able to recover and reuse the solid booster, but you get to examine how it performed, and that makes a huge difference in terms of flying safely. Because, you know, if you look back at the history of the Challenger accident, we knew for many years that we had a problem with blow-by around the O-ring seal. Unfortunately, for various reasons, management chose to ignore that and fly anyway. But if you can recover your rocket after you use it and actually see how it performed and look and see if there are any critical failures which you know are suggesting that there are problems, that also improves your reliability. So we have a lot of experience with 4-segment solid rocket boosters, and by choosing not to use this new improved 5-segment booster for the human launchers, you know, we're basically saying we're going to go with what we have experience
well,
with.
besides
and
that, we don't
understand.
have it in there.
It will be developed in the but if when we
not
develop
between
it,
now and the season.
yeah. But when we develop it and use it for this, you know, someday after we get a lot of experience with it, we may decide to. Well, it says can be certified.
This is
for
now. This
creative
is the heavy
yeah.
lift
Right.
thing, but
But you're going to
intent-
want to fly it many times
yeah.
before we decide.
And the
to
intent
fly
is
through
not
it.
to human rate this from the start. Without the upper stage, you can get 100 tons, 106 tons to low Earth orbit just with the first stage, and 55 metric tons to well, you can read, I think. That's a new development, obviously. This is Marcia Ivins, who presented this yesterday, one of Jeff's former colleagues, said this really isn't what it's going to look like, the lunar lander. What's interesting is, in addition to carrying the crew down, the idea is that you can carry a fairly significant cargo load down to the lunar surface and leave it there, and that enables the fairly early buildup of a lunar base capability. And again, this ascent stage will use a liquid methane propulsion. Well, this is enough for 4 people, so it's not super big. I've seen dimensions on it, but this is just a nominal design anyways. This design with all the tanks down here is not very good for carrying cargo down. They added the cargo capability and didn't change the picture here. Here's what NASA says are the commercial opportunities in this initiative. It's interesting. There were some other ones that have gone away from earlier briefings. Here are the international opportunities, and they're focused in the longer run on lunar surface systems. And the reality is that without international contributions, you can't do a lunar base because on the budget available, you can't afford to build this stuff. I'm looking at this hard for the first time. I saw a version of this in July, and there have been some significant changes. The July version said opportunities for non-U.S. astronauts going to the moon. And it's not here in this final briefing. Okay. Committed long-term lunar effort is needed. This is really a plan. You know, you can show Mars up here, but this is really a plan for getting back to the moon. And to reach for Mars, we must first reach for the moon. A Griffin quote. Mike and I have talked about this. He believes that spread of the human species into the solar system is inevitable, and the United States should lead so we carry the principles and values of Western philosophy and culture. You can make a judgment whether you think that that's a good rationale for doing this or not, but he means it. Great nations do great and ambitious things. We must continue to be great. Cue the music now. This is interesting. This was the presentation I was given yesterday, and it is different than the presentation that was presented to industry yesterday. And the biggest difference is the industry presentation had a budget. And the budget shows that within the next 5 years, all of this fits within the planned budget curve, and then stops in terms of the affordability downstream. And it also shows no Mars research and technology until fiscal 1917, and a fairly big wedge for lunar outpost, which this is a U.S.-only scenario. So any relief from this is going to come from international contributions. And one of the things that changed over the past week or so is now the phrase is "go as you can pay." In the trade between performance, requirements, cost, and schedule, what you're going to trade is schedule. And NASA's very nervous of announcing this thing in the middle of the Katrina recovery, saying, well, we're going to spend $100 billion going back to the moon.
That's the first question that Griffin got.
Yeah, right. And it's what I talked to some media yesterday, and it's the same thing, sort of thing. It's interesting that that budget chart is not in the presentation I was given.
The budget says that they can't do it?
The budget says that they can get started. And
yeah, I mean, what the budget is going to support, and what the hardware that we will be building is, first over the next few years, it's just the crew exploration vehicle
and the launch vehicle.
Yeah,
and the upper stage and the launch vehicle.
Right. This. We'll retire the shuttle. We'll use that to support the space station if we're doing the space station at that point. And not until the shuttle is retired will then the money that is now used to support shuttle flights can start going into building this. That's
Yeah.
the way I understand
Yeah,
it. And
exactly.
and that's the schedule, which means you can't get to the moon until near the end of the next decade. And
2018 is
yeah,
the target date.
And that doesn't support any extra equipment once you get to the surface of the moon. So we don't have a long-term habitat, we don't have rovers, we don't have in situ resource to, all the stuff that we'd like to do on the moon, that's over and above this. I think that's fair to say. Isn't it?
I think it's fair to say, except that it's, as I say, in this budget curve, it's in the budget. But the only way to do the rest of it is to get that green part, the
Right.
lunar base buildup, to be paid for by somebody else.
Right. So we will
This
see.
is your future, I think, if you're going into aerospace engineering. This is at least the NASA project for the next 15 years.
And maybe 20 years from now, there will be a class here talking about the
About this
systems
architect-
engineering of the lunar exploration program. Yeah, so your kids can attend that class.
No, then it was typewritten memos. Now it's PowerPoint.
Yeah.
Yeah, without there for you engineering junkies, there is a 1,000-page report coming next month that has all the information of the trade studies and everything underpinning all this. This is the output of a study. The study report is coming.
Okay, just briefly, I've gotten, from most of you, I've gotten an indication of what you want to do for your projects. I'll have a look at those. If you haven't sent them to me, please make sure I get them by Thursday. One or two of you have said you want to come and talk with me about it. That's fine. Let's see. That's on the reports. And the last thing, just to remind you that this really is the last of the kind of introductory policy. How did the shuttle program get started? We're going to get, from now on, for the next 6 weeks or so, we'll be going deep into the nitty-gritty of some of the systems. So Tom Moser will be here, and he'll be talking about shuttle structures and the thermal protection system on Thursday. See you then.